National Electrical Code Article 427, titled Appliance Circuits, specifically Section 427.23 addresses ground fault circuit interrupter protection for dwelling units. Paragraph B within this section focuses on electrical heat tracing equipment. It states that feeders supplying fixed electrical resistance heat tracing equipment shall be provided with ground fault circuit interrupter protection. This requirement ensures safety by quickly de-energizing the circuit in the event of a ground fault, minimizing the risk of electrical shock and fire. Ground fault circuit interrupters, or GFCIs, are designed to detect even smaller imbalances in current between the hot and neutral conductors. These imbalances often indicate that current is leaking to ground, posing a safety hazard. When a GFCI detects such an imbalance, typically around 5 mA, it trips the circuit, cutting off the power supply. This rapid response is crucial in preventing serious injury or damage. The application of ground fault circuit interrupter protection to electrical heat tracing equipment is particularly important because these systems are often installed in environments where moisture is present. Moisture can compromise the insulation of the heat tracing cable, increasing the likelihood of a ground fault. Furthermore, heat tracing systems may be installed in locations that are readily accessible to people, making the risk of electrical shock even greater. The term fixed electrical resistance heat tracing equipment refers to heating systems that utilize electrical resistance to generate heat and are permanently installed. Examples include heat tape or heat cable used to prevent pipes from freezing, roof and gutter de-icing systems, and soil warming cables. The phrase feeders supplying indicates that the ground fault circuit interrupter protection is required on the circuit that provides power to the heat tracing equipment, not necessarily at the individual branch circuit level. However, depending on the specific installation and local electrical codes, ground fault circuit interrupter protection may also be required at the branch circuit level. Ground fault circuit interrupters are available in several forms, including circuit breakers, receptacles, and portable units. The type of ground fault circuit interrupter used will depend on the specific application and the configuration of the electrical system. For example, a ground fault circuit interrupter circuit breaker can be installed in the electrical pile to protect an entire circuit, while a ground fault circuit interrupter receptacle can be used to protect a single outlet. When installing ground fault circuit interrupter protection for electrical heat tracing equipment, it is important to follow the manufacturer's instructions and all applicable electrical codes. The ground fault circuit interrupter should be tested regularly to ensure that it is functioning properly. Testing typically involves pressing the test button on the ground fault circuit interrupter device, which should cause it to trip. If the ground fault circuit interrupter does not trip when the test button is pressed, it should be replaced immediately. In addition to the requirements outlined in National Electrical Code Article 427.23, there may be other applicable codes and standards that must be followed. For example, some jurisdictions may require that all electrical work be performed by a licensed electrician. It is always best to consult with a qualified electrician to ensure that the installation is safe and compliant with all applicable regulations. It is also important to note that ground fault circuit interrupter protection is not a substitute for proper grounding and bonding. Grounding and bonding are essential for providing a low impedance path for fault current to return to the source, which helps to protect against electrical shock and fire. The National Electrical Code provides detailed requirements for grounding and bonding in Article 250. In summary, National Electrical Code Article 427.23b mandates ground fault circuit interrupter protection for feeders supplying fixed electrical resistance heat tracing equipment in dwelling units. This requirement is intended to enhance safety by preventing electrical shock and fire hazards. When installing and maintaining electrical heat tracing equipment, it is essential to adhere to all applicable electrical codes and standards, and to consult with a qualified electrician as needed. Proper ground fault circuit interrupter protection, combined with proper grounding and bonding, provides a comprehensive approach to electrical safety. Furthermore, it's crucial to understand the difference between ground fault circuit interrupters and arc fault circuit interrupters. While both are safety devices, they protect against different types of electrical faults. Ground fault circuit interrupters, as discussed, protect against ground faults, which occur when current leaks to ground. Arc fault circuit interrupters, on the other hand, protect against arc faults, which are dangerous electrical arcs that can occur due to damaged wiring or loose connections. Arc fault circuit interrupters are designed to detect these arcs and trip the circuit, preventing fires. In many jurisdictions, arc fault circuit interrupter protection is required for branch circuits that supply outlets in dwelling units, particularly in bedrooms and other living areas. It's important to use the correct type of protection for the specific hazard. Using a ground fault circuit interrupter in place of an arc fault circuit interrupter, or vice versa, will not provide the intended level of protection. When working with electrical heat tracing equipment, it is also important to consider the ambient temperature and the insulation of the wiring. The National Electrical Code provides guidance on selecting the appropriate wiring for different temperature conditions. Wiring that is exposed to high temperatures may need to be rated for high temperatures to prevent the insulation from degrading. Similarly, wiring that is exposed to moisture or corrosive environments may need to be protected by a suitable conduit or enclosure. The selection of appropriate wiring and protection methods is crucial for ensuring the long-term reliability and safety of the electrical system. In addition to the specific requirements for ground fault circuit interrupter protection, there are also general requirements for the installation and use of electrical equipment. These requirements are outlined in the National Electrical Code and other applicable standards. For example, all electrical equipment must be listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories or Canadian Standards Association. This listing indicates that the equipment has been tested and found to be safe for its intended use. Electrical equipment must also be installed in accordance with the manufacturer's instructions and all applicable codes. Improper installation can create safety hazards and void the manufacturer's warranty. Finally, it is important to maintain electrical equipment in good working order. Regular inspections should be conducted to identify any signs of damage or deterioration. Any damaged or defective equipment should be repaired or replaced immediately. Proper maintenance is essential for ensuring the continued safety and reliability of the electrical system. When selecting electrical heat tracing equipment, it is important to choose products that are specifically designed for the intended application. There are many different types of heat tracing cable available, each with its own characteristics and limitations. For example, some heat tracing cables are designed for use in wet locations, while others are not. Some heat tracing cables are self-regulating, meaning that they automatically adjust their heat output based on the ambient temperature. Others are constant wattage, meaning that they produce a constant amount of heat regardless of the ambient temperature. The selection of the appropriate type of heat tracing cable will depend on the specific requirements of the application. It is also important to consider the power requirements of the heat tracing equipment. The circuit supplying the equipment must be sized appropriately to handle the load. The National Electrical Code provides guidance on calculating the load and selecting the appropriate circuit size. Overloading a circuit can cause the circuit breaker to trip or, in more severe cases, can lead to a fire. In addition, the heat tracing equipment must be properly grounded. Grounding provides a low impedance path for fault current to return to the source, which helps to protect against electrical shock and fire. The National Electrical Code provides detailed requirements for grounding in Article 250. When installing heat tracing equipment, it is important to follow the manufacturer's instructions carefully. The instructions will provide guidance on how to properly install the equipment and how to avoid potential hazards. It is also important to use the correct tools and equipment for the job. Using the wrong tools can damage the equipment or create safety hazards. Finally, it is important to test the installation after it is complete to ensure that it is working properly. Testing can be done using a multimeter or other appropriate test equipment. The test should verify that the equipment is receiving power and that it is producing heat. If the equipment is not working properly, it should be inspected and repaired or replaced as necessary. Regarding the initial question about finding the article that states heat tape or heat cable has to have ground fault circuit interrupter protection, National Electrical Code Article 427.23b specifically addresses this requirement for dwelling units. This section mandates the use of ground fault circuit interrupter protection for feeders supplying fixed electrical resistance heat tracing equipment. The user's mention of Article 424 is related to fixed electric space heating equipment, which may or may not include heat tracing, and Article 500.13e pertains to hazardous locations, which is not relevant to a typical dwelling unit installation of heat tape for freeze protection. Therefore, focusing on Article 427.23b provides the correct code reference for ground fault circuit interrupter protection of heat tape in residential applications. The purpose of requiring ground fault circuit interrupter protection is to protect people from electrical shock. Heat tape and heat cables are often installed in areas where they may come into contact with water, such as around pipes. If the heat tape or cable becomes damaged, it could create a path for electricity to flow to ground, potentially shocking someone who touches it. Ground fault circuit interrupters are designed to detect these ground faults and quickly shut off the power, preventing electrical shock. Ground fault circuit interrupters are required in many areas of a dwelling, including bathrooms, kitchens, and outdoor locations. The specific requirements for ground fault circuit interrupter protection are outlined in the National Electrical Code. It is important to consult the National Electrical Code and any local codes to ensure that all electrical installations are safe and compliant. When installing heat tape or heat cable, it is important to follow the manufacturer's instructions carefully. The instructions will provide guidance on how to properly install the equipment and how to avoid potential hazards. It is also important to use the correct tools and equipment for the job. Using the wrong tools can damage the equipment or create safety hazards. For instance, using the wrong type of fastener can puncture the heat tape, creating a shock hazard or fire risk. Ensuring the heat tape is not bent sharply, overlapped, or damaged during installation is also important. A qualified electrician should perform any electrical work. A qualified electrician has the training and experience necessary to install electrical equipment safely and correctly. Hiring a qualified electrician can help to ensure that the installation is compliant with all applicable codes and that it is safe for people and property. If you are unsure about any aspect of the installation, it is always best to consult with a qualified electrician. They can provide guidance and ensure that the installation is done safely and correctly. It is also important to remember that ground fault circuit interrupters are not a substitute for proper grounding and bonding. Grounding and bonding are essential for providing a low impedance path for fault current to return to the source, which helps to protect against electrical shock and fire. The National Electrical Code provides detailed requirements for grounding and bonding in Article 250. Furthermore, while Article 427.23b mandates ground fault circuit interrupter protection for heat tracing equipment, it is crucial to understand the scope and limitations of this requirement. The code specifically applies to fixed electrical resistance heat tracing equipment. This means that the requirement applies to heat tracing systems that are permanently installed and use electrical resistance to generate heat. Portable heat tracing devices, such as those used for temporary freeze protection, may not be subject to the same ground fault circuit interrupter requirements. However, it is always best practice to provide ground fault circuit interrupter protection for any electrical equipment that is used in wet or damp locations or that is likely to come into contact with water. In addition to the National Electrical Code, there may be other applicable codes and standards that must be followed. For example, some jurisdictions may have local amendments to the National Electrical Code or may have their own electrical codes. It is important to consult with a local electrical inspector to ensure that the installation is compliant with all applicable regulations. The electrical inspector can provide guidance on the specific requirements for ground fault circuit interrupter protection and other electrical safety measures. They can also inspect the installation to ensure that it is done safely and correctly. Obtaining the proper permits before starting any electrical work is also important. Permits are required for most electrical installations and alterations. Obtaining a permit ensures that the work will be inspected by the local electrical inspector and that it will be compliant with all applicable codes. Working without a permit can result in fines and penalties. It is important to remember that electrical safety is not just the responsibility of the electrician or contractor. Everyone has a role to play in ensuring that electrical equipment is used safely and correctly. Homeowners should inspect their electrical systems regularly for any signs of damage or deterioration. They should also be aware of the potential hazards associated with electricity and take steps to avoid them. Never overload circuits or extension cords. Do not use electrical appliances near water. Keep the electrical cords away from heat and sharp objects. If you see any sparks or smoke coming from an electrical outlet or appliance, turn off the power immediately and call a qualified electrician. By following these simple precautions, you can help to prevent electrical accidents and injuries.